Okay, so these are questions number 38 and 39, the last two questions of the magnetic fields homework booklet. So in question number 38, we're asked which one of these four statements down here concerning power losses in a transformer is incorrect. So this is very similar to a question that we've kind of had before. So looking at this, power losses can be reduced by A, laminating the core. Well, that's definitely true, because if we laminate the core, we can reduce eddy currents, and if we reduce eddy currents, then we reduce heating effects in the core. If we use high resistance windings, then basically what that means is that the resistance of our wires are bigger. If the resistance is bigger, then the I squared R heating effects, the Joule heating effects, are bigger, so we lose more energy, so therefore the answer is B. For C, using thicker wire, that would reduce power losses, because if we use thick wires, then that basically means the resistance goes down, and for exactly the opposite reasons for part B, that's why it can't be C. And D, using a core made of special iron alloys which are easily magnetized. Well, that means that the core is magnetically soft, it's easily magnetized, so less energy is lost in actually the process of magnetization and demagnetization. So again, your core doesn't heat up so much. So therefore your answer for question 38 is B. For question number 39, question 39 is got lots of information. So what we've got is we've got a transformer that's got 3,000 turns on its primary coil, and it's used to change an alternating potential difference from a root mean squared value of 240 volts to a root mean squared value of 12 volts. We then have a 60 watt 12 volt lamp that's connected to the secondary coil, so we've got a circuit, and the lamp lights at normal brightness, and a root mean squared current of 0.26 amps passes through the primary coil. So we know what the current on the primary side is, we also know what the potential difference on the secondary side is, and we also know that on this side you must have 60 watts of power, because if the lamp is lighting at its normal brightness, it must have 12 volts and 60 watts to work. So there, we're then asked which of these lines, A, B, C or D, gives the correct values for the number of turns on the secondary coil and also for the transformer efficiency. So we're going to take it as two steps. First of all, we're going to do this. So in order to work out the number of turns on the secondary coil, we simply use this equation here. So this is our transformer equation. If we rearrange it, then the number of turns on the secondary coil are equal to the number of turns on the primary coil multiplied by the potential difference on the secondary coil divided by the potential difference on the primary coil. So if we go back and have a look at this, the number of turns on the primary coil are here, 3,000 turns. The potential difference on the secondary side is 12 volts, because that says here. So it's got a root mean squared value of 12 volts. And it also told us that we've got a root mean squared potential difference of 240 volts on the primary side. So if we just take this and we put that into our equation, we get 150 for the turns on the secondary coil, which means that it's either A or it's C. It can't be B or D. So we've narrowed it down to 2, but we now need to work out whether it's A or C. So we'll look at the efficiency. So the efficiency is the power going out on the secondary side divided by the power going in on the primary side. The power going out must be 60 watts. We know it has to be 60 watts due to the fact that this bulb lights up at its normal brightness. The power in is equal to the current going in on the primary side multiplied by the potential difference going in on the primary side. So what we have is we have this power here divided by this power here when we multiply these two numbers together, and that gives an answer of 0.9615, etc. So as a percentage, the efficiency is 96%. And so if we go back up here, we'd already chosen A or C. It's not C, so therefore it must be A. So our answer to the final question in this homework booklet was A. So that was question number 38 and 39, the last two questions in your magnetic fields homework booklet.